Friday, April the 12th through the 16th. We're going to be looking at lesson 32, graphing systems of equations. Before we start our lesson, there's just a couple of things I want to talk to you about. Suppose that we have point A, and it has coordinates 1, 3. Alright? What if I tell you to find the distance between A and B? Alright? And in this case, we'll let B have the coordinates of 4, 2. Alright? How would I figure this out? Well, they don't share x's and they don't share a y coordinate. So how would I figure out how to find the distance between these? At this point in time, I would have to use the distance formula. And the distance formula looks like this. I'm going to subtract my x coordinates and square that, and then subtract my y coordinates and square that. So, if I wanted to find the distance between A and B here, then I'm going to, and it doesn't matter if I start with point A or point B, the only thing is if I start with point A here, I have to start with point A here. Alright, so make sure that your starting point is always the same point. Alright, so I'm going to do the distance is equal to the square root of, let's start with B, so 4 minus 1 squared plus 2 minus 3 squared. Since I started with point B at my x coordinates, I'm going to start with point B on my y coordinates. Alright, so I get 3 squared plus negative 1 squared. Alright, 3 squared is 9 plus negative 1 squared is 1. So I get the square root of 10. I cannot simplify that anymore. 5 and 2 or 1 and 10. None of those are perfect squares. So I can say that the distance here is the square root of 10. Alright. Let's do one more. Let's say that B has the coordinates of negative 3, 1. Alright. So distance is equal to the square root of negative 3 minus 1 squared plus 1 minus 3 squared. Alright, so I get the square root of negative 3 minus 1 is negative 4 squared plus 1 minus 3 is negative 2 squared. So I get negative 4 squared is 16 plus negative 2 squared is 4. I get the square root of 20. I can break that up into the square root of 5 times 4. Square root of 4 is 2. I cannot take the square root of 5. So my answer here, in this case, is 2 square root of 5. Alright? So I can use the distance formula when I'm given 2 points, x1, y1, and x2, y2, to find the distance between the points that are given in a formula. Alright? Alright. So let's go ahead and look at our lesson. It's called Graphing Systems of Equations. Alright, so given the line y is equal to 2x, is there a point on the line at a distance 3 from 1, 3? Okay. Explain how you know. Alright, so once again, we are given a line, y is equal to 2x, and it wants to know, is there a point on that line at a distance of 3 from the point 1, 3. Alright, so here's what I can do. I'm going to go ahead and graph that line. And the second part here says the graph. So we'll go ahead and graph that line. Alright? Okay, so in graphing that line, I'm going to do, it crosses at 0, 0, because there is no y, or the y-intercept is 0, and my slope is 2. So up 2 over 1, up 2 over 1. So here is my line. Alright, so it wants to know, is there a point on the line at a distance 3 from 1, 3? So 1, 3. Here is that point. Alright. How do we figure this out? Well, if I want to, in the last lesson we talked about circles and lines and where they can intersect, and could they intersect, do they have to intersect? So let's think about this for a second. If I draw a circle, alright, let's say that I want to draw a circle with 1, 3 being a point on that circle. Alright? Then I can do that. So the equation of a circle looks like this. So my x-coordinate is 1, so x minus 1 squared plus y minus my y-coordinate is 3, alright, squared is equal to 9. So if I create a circle at this equation, alright, then I'm going to see that there are 2 points that that I can get with the distance of 3. Alright? You would need a graphing calculator, Desmos something, and what you would do is you would trace and see that there are actually 2 graphs, or 2 points on that graph. Alright? Let me go ahead and graph this for you. And I'm going to graph y is equal to 2x. And then I'm going to graph if I can get it. X minus 1 squared plus y minus 3 squared is equal to 9. Alright, so here I have graphed it. This is what my graph would look like. Alright, and then I can trace this and see where my points, and notice, here's this point, 1, 3, that is my center of my circle. Excuse me. That is the center of my circle. Alright. So therefore, I would be able to see that there are 2 points alright, and those 2 points are roughly 0 and 7/100 and 0 and 15/100 and 2 and 73/100 and 5 and 45/100. Alright? So I would see that that is roughly where it would be. Alright, and I'm going to draw roughly this circle just because I'm not the greatest circle drawer. But you would see that that is what my graph would look like. So roughly here and here is where it would touch. Alright? And actually I drew that wrong because it doesn't go below the or the x-axis. So here's my circle. Alright? Alright. Solve the system x minus 1 squared plus y minus 2 squared is equal to 2 squared, and y is equal to 2x plus 2. Okay, once again, guys, you know this is a circle because of the way it is set up. Alright, this is the equation of a circle, this is the equation of a line. Alright, so we'll go ahead and see what we can do here. I would suggest substitution because this is a systems of equations. Go ahead and substitute. Now that I know that y is equal to 2x plus 2, I can substitute that in for y of this equation. So this is what I end up with. X minus 1 squared plus, I know that y is 2x, and I'm going to have a second set of parentheses, 2x plus 2 minus 2 squared is equal to 2 squared. Alright, so let's go ahead and solve this. So I get x squared, negative 1 plus negative 1 is negative 2x plus 1, and I just got that by multiplying that out, plus, I get 2x plus 2 minus 2 cancel out, so I get 2x squared is equal to 2 squared is 4. So I get x squared minus 2x plus 1 plus, square this, I get 4x squared is equal to 4. Combine my like terms, so 5x squared minus 2x plus 1 is equal to 4. I would suggest that you bring the 4 over. 5x squared minus 2x minus 3 is equal to 0. And at this point in time, I need to factor it. Alright, so we'll factor, and we'll do 5x and x because that is really the only way to factor 5. Alright, and then I need to be able to factor 3 to get 2. Got to be really careful because this is a 5. So if I do 3 and 1, this is going to be negative, this is going to be positive. And remember, I can set each of these equal to 0 and solve. So I get x is equal to negative 3/5. And x is equal to 1. Alright? So, when I figure that out, then I can figure out what my y is. Alright, so I would just go back in and substitute. Alright, you can substitute it into either equation, it doesn't matter really. I would suggest this one because it's the simplest. So y is equal to 2 times negative 3/5 plus 2. So y is equal to negative 6/5 plus 2. 6/5 is the same as 1 1/5. So if I'm taking 1 1/5 away, I end up with 4/5. Alright, so I know that when x is negative 3/5, then y would be 4/5. So that's one intersection. Alright, go ahead and plug in the 1. So y is equal to 2 times 1 plus 2. So that would be 2 plus 2, which is 4. So the other intersection would be when x is 1. It would intersect at 1, 4. Alright. So what are the coordinates of the center of the circle? I know that by looking at my equation of the circle. My x would be the opposite of negative 1, which is positive 1. And the y coordinate would be the opposite of negative 2, which is positive 2. Alright, so that's the center of my circle. What can you say about the distance from the intersection points to the center of the circle? Well, because they are points on the circle and the radius of the circle is 2, the intersection points are 2 units away from the center. Alright? So, since the points on the circle and the circle has a radius of 2, alright, and I know that by looking at my point, then the intersection points are 2 units away from the center. And you can verify this using the distance formula. We aren't going to do that right now, but you can use distance formula. Alright, so it says using your graphing tool, graph the line in the circle. Alright, when I do that, let me go ahead and hit Doc B. And we'll go ahead and graph these. So we get y is equal to 2x plus 2. And hit enter, and then we've got a circle, so we're going to graph a relation of x minus 1 squared plus y minus 2 squared is equal to 4. And here is my graph. This is what it looks like. Alright, so you can kind of draw. We aren't going to make it perfect. Alright, but we can kind of see. And so these 2 points right here are our intersection points. Alright. Alright, example number 1. Rewrite x squared plus y squared minus 4x plus 2y is equal to negative 1 by completing the square in both x and y. Describe the circle represented by this equation. Alright, so the first thing we're going to do is we're going to rearrange it, and we need to put our x's together and our y's together. Alright, so we're going to rearrange this to x squared minus 4x plus y squared plus 2y is equal to negative 1. Alright? Now, we've done completing the square. It's been a while. So, let's just kind of go back through and remember this. Alright, so, excuse me. I'm going to break up the x squared, or take the x's away, and we have to take half of the 4, which is 2, and then square it. So that would be 4. Now, I'm going to show you something. Give me just a minute. Let me finish this part. Y squared plus 2y. We're going to take half of the 2, which is 1, and square it, which is 1. But because I do it to one side, remember we have to do it to both sides. So I'm going to have to add that 4 to this side and add that 1 to that side. Alright, so then this is what we get. When I factor this, I get x and x, 2 and 2. And then I get y, and 1 and 1 is equal to 4. Alright, so the equation of my circle would look like this. X minus 2 squared plus y plus 1 squared is equal to 4. And it says describe the circle represented by this equation. I can tell what the center of my circle is. Remember, the center of my circle is the opposite of -2, which is 2, and the opposite of 1, which is -1. So the center of my circle is 2, -1. And I know that it has a radius because I can take the square root of this, alright, and gives me a radius of 2. Alright. Using your graphing tool, graph the circle. Alright. So, like I said, guys, if you have Desmos, which everybody can get to Desmos, all you have to do is go to desmos.com. Use that to try to graph this. I'm going to do my best to try to get you for you to be able to see what it looks like. So I have x minus 2 squared plus y plus 1 squared is equal to 4. Here's my circle. Alright. It's a little hard to see, but we can go ahead and graph it. Alright. Just out to the side. Once again, we won't do, it doesn't have to be perfect, but you can see it looks like this. Alright. In contrast, consider the following equation: x squared plus y squared minus 2x minus 8y is equal to -19. Alright, so now it wants us to rearrange it, and so we've got x squared minus 2x plus y squared minus 8y is equal to -19. Alright, so let's complete the square. X squared minus 2x, I'm going to take half of 2, which is 1, square it, that's 1. Y squared minus 8, take half of 8, which is 4, square it, that's 16. Now because I did it to one side, I have to add 1 and 16 to both sides. Alright, so looking at this, let's see if I can factor. So I get x and x, 1 and 1, they're both negative, plus y, -4, -4. -19 plus 1 is -18, -18 plus 16 is -2. So this is what I get: x minus 1 squared plus y minus 4 squared is equal to -2. I know something about this. It is not a circle because in this case, the square root, or the radius, would have to be the square root of -2. And I cannot do that. So it's not a circle, because the radius would have to be the square root of -2. That will not work. Alright, that will not work. What happens when you're using your graphing tool in this equation? Well, let's look and see what happens. When I graph this, alright, let's see what it tells me. So I have x minus 1 squared plus y minus 4 squared is equal to -2. It didn't do anything. The tool cannot draw this graph. Alright, there's no point that satisfies this equation. So it can't draw it. There is no center point here that I can do. Alright, consider a circle with radius 5 and another circle with radius 3. Let D represent the distance between the two centers. We want to know how many intersections there are of these two circles for different values of D. Draw figures for each case. Alright. So it says, what happens if D is equal to 8? Alright. Consider the circle with a radius of 5. Alright. And another with a radius of 3. So I've got 3 and I've got 5. And it says, let D represent the distance between the two centers. Alright, so we've got the two centers. So if the distance is 8 between the two centers, then let's think about this. Okay, so let's say that this is the center for one circle. Alright, and it has the radius of 5. And the other circle has a radius of 3. If I want the distance to be 8, at this point in time, I'm going to see that those two circles will only intersect at one point. They will touch at one point. Okay? They will touch at one point. We call these externally tangent. Alright? We call this externally tangent. They intersect at, or they touch at one point. Alright? What happens if the distance is 10? Well, once again, let's look at those two circles. If I have a distance of 5, and one has a radius of 3, is there any way for me to have a distance of 10 between those circles? Well, here, this would have to be 2. Alright, so that would be the distance of 10. So what would happen? That if the distance is 10, they do not intersect. Okay? They do not intersect. One circle is outside of the other. So let's talk about what happens if the distance is 1. Alright, if the distance is 1, well, I don't know what that would look like. So here's my circle with a radius of 5. I only want it to be a distance of 1. Alright, so they would not intersect, but one circle lies inside the other. Alright, what if I want the distance of 2? Alright, a distance of 2. Well, there's that 5, and I want them to be a distance of 2, which means they would touch at 1 point. Alright? They would touch at 1 point. In this case, because one circle is inside the other, and they touch at 1 point, we call this internally tangent. Alright? Because one lies inside the other and they touch at 1 point, we call this internally tangent. Up here, remember, they were side by side and they touched at 1 point, so we call that externally tangent. Alright? For which values of D, excuse me, do the circles intersect in exactly 1 point? Well, that would be D is equal to 8. Alright. And then D is equal to 2. Alright. Generalize this result to circles of any radius. So these circles would be tangent. We just said that they were internally or externally tangent. Okay? These circles would be tangent. So, generalize, so we need to do something in general. If D is either the sum or the difference of the radii, then the circles will be tangent. So if the distance is either the sum or the difference of the radii, the circles are tangent. Alright, so the radius of the radii of the two circles were 5 and 3. So 5 plus 3 was 8. Alright. Then if I looked at the fact of the difference, 5 minus 3 was 2. So if it's the sum or the difference of the two radii, then we are going to have tangent circles. Alright? So for which values of D do the circles intersect in 2 points? Alright. Generalize the results of the circle. So where do they intersect at 2 points? Well, we never did see one that had 2 points. So if it would have to fall somewhere between 2 and 8. So if 2 were less than D were less than 8, the circles would intersect in 2 points. Alright? And we did not see that in any of our examples. Alright? Alright, for which values of D do the circles not intersect? So we said if D was equal to 10, they wouldn't intersect. And if D was equal to 1, they would not intersect. So here in generalizations, D had to be less than 2, or D had to be greater than 8. Alright, so if D is less than 2, if our distance is less than 2, or if our distance is greater than 8, they would not intersect. Alright, and I can put these in generalization with any 2 circles. Alright guys, we are just about finished. This was kind of a long lesson. A lot of material in it. Alright, find the distance between the center of the circles with equations below and use the distance to determine how many points these circles intersect. Alright, so the first thing I need to know is what is the center of my circle. Alright, so the center of my first circle, because there is nothing attached to the x or the y, the center here is 0, 0. Alright, and then here, the center of my second circle is the opposite, so 2, 1. Alright, so now using the distance formula, I can find the distance between my 2 circles. So D is equal to 2 minus 0 squared plus 1 minus 0 squared. So 2 squared is 4, and 1 squared is 1. So I get the square root of 5. Since the distance between the centers is between the sum and the difference of the 2 radii, alright, so look at this. My radii would be the square root of 5 and the square root of 3. Alright. So I can look at this and I can see that the square root of 5 is between, if I add these together, the square root of 5 and the square root of 3, let's just kind of look at this. We'll take 5, the square root of 5 is approximately 2.24. So if I take 2.24 and add the square root of 3, 1.73, or if I take 2.24 and subtract, then I'm going to see that my distance is between those 2 sums or differences. Alright, so we said if it was between, going back to our general, if it is somewhere between, they would intersect at 2 points. Alright? So they intersect at 2 points, since my distance is between my sum or difference and my radii. Alright? Alright. Let's look at exercise 3. Use the distance formula to show algebraically and graphically that the following 2 circles do not intersect. Once again, find your centers. Alright, so the center of this circle is 1, negative 2. The center of this circle is negative 5, 4. I know that the radii are the square root of 1 and the square root of 4, which is the square root of 1 and 2. Alright? So now that I know my centers, I can do the distance formula, which, guys, square root of 1 is 1, by the way. I didn't catch that. So I can do the distance of my centers. So I've got 1 minus 5. So 1 minus a negative 5 would be 1 plus 5 squared. Plus negative 2 minus 4 squared. So I get 6 squared, which is 36. Plus a negative 6 squared, which is 36. So I get the square root of 72. Alright. So the distance is 72. I can split that into the square root of 36 times 2, which is 6 square root of 2. Alright. So, looking at this, I've got 1 plus 2, or 2 minus 1. So it would have to be somewhere between 3 and 1. Alright, so let's look at 6 square root of 2. Let's take the square root of 2 and multiply that times 6. It is somewhere between, it is around 8 and a half. So my distance is bigger than the sum or the difference. Alright, so that means, if we go back, if it is bigger than the sum or the difference, then they do not intersect. And I can graph these to prove it, but I won't spend that time because our video is getting a little long here. Alright? Example number 3. Point A, 3, 2, is on a circle whose center is C, negative 2, 3. What is the radius of the circle? So I've got 2 points. It says the points on this circle, and this is my center. I can do the distance formula. So 3 minus a negative 2 is 3 plus 2 squared, plus 2 minus 3 squared. I get 5 squared, which is 25, plus negative 1 squared is 1. So I get the square root of 26. Alright. That is the length of my radius. What is the equation of the circle? Alright, so I'm going to use my center to write my equation. So x, remember it is the opposite. So if the center is negative 2, I'm going to do positive 2 squared plus y. If it's a positive 3, the opposite of that is negative 3 squared is equal to, I square my radius, 26, a square root of 26 squared is 26. Alright? And then it says graph it, but we're not going to worry about that. Alright, last few questions. Use the fact that the tangent at A, 3, 2 is perpendicular to the radius at that point to find the equation of the tangent line, then graph it. Now remember, if it's tangent, then that means that they are either outside and touch at one point or inside and touch at one point. Alright, so the slope of a tangent line is the opposite reciprocal of the slope of AC. Alright, so we've got to find the slope of our AC. Alright, so if A is 3, 2, and our center is negative 2, 3, remember we find our slope like this. So 3 minus 2 over negative 2 minus 3, so that is 1 over negative 5 or negative 1/5. So the slope of the tangent line is the opposite reciprocal. So the slope of the tangent is 5. All right? So using the point slope form of the equation of the line with slope 5 and passing through point 32, we're going to get this equation. Y minus 2 is equal to my slope times x minus 3. So I get y minus 2 is equal to 5x minus 15. Go ahead and solve that. So y is equal to 5x minus 13. So that is the equation of the tangent line. All right? Find the coordinates of point B, the second intersection of the line AC and the circle. All right, so I'm going to use the equation of my circle, all right, which was x plus 2 squared plus y minus 3 squared is equal to 26. And then I'm going to use the equation of my tangent line, I'm going to use the equation of my original line, which was 5y is equal to negative x plus 13. All right? And I can solve. All right? So if I solve for x here, then I can plug it in here. So x is equal to negative 5y plus 13. All right, so plug that back in. So I get negative 5y plus 13 plus 2 squared plus y minus 3 squared is equal to 26. All right, so I get negative 5y plus 15 squared plus y minus 3 squared is equal to 26. All right, so I'm trying to find the coordinates of the second. All right, so go ahead and with this one, we're going to have to solve it out. So I get 25y squared. This is going to be a big one. So I get negative 75, negative 75 is negative 150y plus 225 plus y squared minus 6y plus 9 is equal to 26. All right, so I get 26y squared, negative 156y plus 234 is equal to 26. All right. Bring your 26 over. I get 26y squared minus 156y plus 234 minus 26 is 208 is equal to 0. Here's what I would suggest you do. I would take out 26, and that gives me y squared minus 6y. Let's see, 208 divided by 26 plus 8 is equal to 0. So much simpler in factoring. Y and y, 4 and 2. All right, and so then I see that y would be, y is equal to 4 or y is equal to 2. Alright, so I have to plug in. So if y is equal to 4, alright, if y is equal to 4, plug it back in, I get negative 20. So I would get negative 20 plus 13. Y would be, or x would be 7, negative 7, 4. Alright, so that is the point that, that's the second point that it crosses. What is the equation of the tangent to the circle at negative 7, 4? Graph it as a check. Use the point slope form of the line with a slope of 5. Remember, with our tangent, our slope is 5. Graph it as a check. So let's do that. So I get y minus 4 is equal to, my slope is 5, x minus a negative 7, which is x plus 7. So y minus 4 is equal to 5x plus 35. Take your 4 over, y is equal to 5x plus 39. Alright, so that's the equation of the tangent line. Alright, when you graph this one, this is what it's going to kind of look like. You're going to get this circle here, and then you're going to get a line that goes right here, and you're going to get a line that goes right here. Alright. The lines y is equal to 5x plus b are parallel to the tangent line to the circle at points A and B. How is the y-intercept b for these lines related to the number of times each line intersects the circle? Okay. When b is equal to negative 13, or b is equal to 39, the line is tangent to the circle, intersecting at one point. Alright? When b is equal to negative 13, or b is equal to 39, now remember, we know this because of our differences or our sums. The line is tangent to the circle, intersecting at one point. Okay? When negative 13 is less than b is less than 39, alright, the lines intersect the circle, the line intersects at 2 points. Alright, and when b is less than negative 13, or b is greater than 39, the line and the circle do not intersect. Okay? Alright, I realize this was a lot of information. I really think that we're only going to do one lesson this week, just simply because it's going to take me some time to get through this one in class. So you only have one lesson this week. We'll get back into 2 lessons next week. Guys, have a great week, and I will talk to you later.